Information Theory, IIT. Title: Understanding Consciousness, Integrated Information Theory, IIT. Hello and welcome to this lecture on one of the most profound and complex topics in contemporary science and philosophy, the study of consciousness. Today, we will delve into the Integrated Information Theory, or IIT, which offers a compelling framework for understanding consciousness. Part 1: The Problem of Consciousness. Consciousness is the state of being aware of and able to think about one's own existence, thoughts, and surroundings. It's what makes the experience of being alive rich and meaningful. Despite being fundamental to our existence, consciousness is notoriously difficult to define and study. Part 2: Introducing Integrated Information Theory, IIT. Integrated Information Theory, developed by neuroscientist Giulio Tononi, is one of the leading theories attempting to explain the nature of consciousness. IIT posits that consciousness corresponds to the ability of a system to integrate information. Part 3: Core Concepts of IIT. Let's break down the core concepts of IIT. 1. Information and integration. IIT begins with the notion that a system is conscious to the extent that it can integrate information. Information here is defined not just as raw data, but as data that is integrated in a meaningful way by the system. The theory uses a mathematical measure called phi, to quantify the level of integrated information in a system. Higher phi values indicate higher levels of consciousness. 2. 5 axioms. IIT is built on 5 axioms that are assumed to be self-evident truths about consciousness. 1. Existence. Consciousness exists, and it is undeniable to the subject experiencing it. 2. Composition. Consciousness is structured. Different experiences are composed of distinct parts. 3. Information. Each experience is specific, differing in its unique way from other possible experiences. 4. Integration. Consciousness is unified. It cannot be subdivided into independent components. 5. Exclusion. Each experience is definite. There is a particular set of contents and boundaries to each conscious state. 3. Physical substrate. According to IIT, consciousness is not an abstract concept, but is directly related to the physical substrates in the brain. These substrates are neural structures capable of generating hyphae, such as the thalamocortical system in humans. Part 4: Measuring Consciousness. One of the remarkable aspects of IIT is its proposal of a practical method to measure consciousness through phi. Researchers use complex mathematical models and empirical data to estimate phi in different systems, ranging from human brains to potential artificial intelligence. Part 5: Implications and Applications. IIT has profound implications for various fields. 1. Neuroscience. It guides neuroscientists in identifying which brain structures are involved in consciousness and how different regions integrate information. 2. Artificial intelligence. IIT raises questions about machine consciousness, suggesting criteria for assessing whether an AI system could be conscious. 3. Ethics. Understanding consciousness can inform ethical considerations regarding treatment of animals, AI, and patients with disorders of consciousness. Part 6: Criticisms and Challenges. While IIT is a groundbreaking theory, it is not without its criticisms. 1. Complexity and mathematical rigor. The mathematical formulation of phi is highly complex and not easily applicable to all systems. 2. Empirical validation. There is ongoing debate about the empirical validation of IIT, with some critics arguing that the theory's predictions are difficult to test. 3. Philosophical issues. IIT faces philosophical challenges, particularly in explaining the subjective quality of experiences and bridging the gap between physical processes and conscious experience. Conclusion: Integrated Information Theory offers a fascinating and comprehensive framework for understanding consciousness, combining rigorous mathematical analysis with deep philosophical insights. While it presents significant challenges, both theoretically and empirically, it continues to inspire and guide research in the quest to unravel the mysteries of consciousness. Theory. Hello and welcome to this lecture on one of the most intricate and influential music theories of the 20th century, serialism. This theory revolutionized the way composers approached musical composition and remains a cornerstone of modern music theory. Part 1: Historical Context. To understand serialism, we must first delve into its historical context. Serialism emerged in the early 20th century as a response to the perceived limitations of tonal music. Composers sought new ways to structure their compositions, leading to the development of atonality and eventually serialism. Part 2: Foundations of Serialism. Serialism was developed primarily by Arnold Schoenberg and his students, Anton Webern and Alban Berg, collectively known as the Second Viennese School. Schoenberg's pioneering work in this field laid the groundwork for a new approach to composition. Part 3: Core Concepts of Serialism. Let's break down the core concepts of serialism. 1. 12-tone technique. At the heart of serialism is the 12-tone technique. This method involves arranging the 12 notes of the chromatic scale into a specific sequence called a tone row or series. The tone row serves as the basis for a composition, ensuring that no single note is given more importance than the others, thus avoiding traditional tonal centers. 2. Permutations of the tone row. The tone row can undergo various transformations to create different versions, including prime form, the original sequence; inversion, flipping the interval directions of the prime form; retrograde, reversing the order of the prime form; retrograde inversion, reversing the order of the inverted form. These transformations provide a rich array of melodic and harmonic possibilities. 3. Serial procedures. Serialism extends beyond pitch organization to other musical elements such as rhythm dynamics and articulation. This comprehensive application of serial principles to multiple musical parameters is known as total serialism. Part 4: Compositional Techniques. Serialism offers composers a structured yet flexible framework for creating music. Some common techniques include: 1. Combinatoriality. This technique involves combining different segments of a tone row to form new rows with shared properties. It allows for intricate relationships between various sections of a composition. 2. Klangfarben melody. Popularized by Webern, this technique, meaning sound color melody, focuses on timbral variations. Different instruments play single notes of a melody, creating a mosaic of sound colors. Integral serialism. This approach, developed by composers like Pierre Boulez and Karlheinz Stockhausen, applies serial principles to every aspect of music, including duration, dynamics, and articulation, creating highly organized and complex works. Part 5: Key works and composers. Some seminal works and composers in the realm of serialism include: 1. Arnold Schoenberg. His Suite for Piano, Opera 25, is one of the earliest examples of 12-tone composition. 2. Anton Webern, known for his concise and highly structured works such as the Symphony 1. 3. Alban Berg combines serialism with expressive romantic elements in works like the Lyric Suite and the opera Wozzeck. 4. Pierre Boulez, a leading figure in integral serialism, known for works like Structures 1 for 2 pianos. 5. Karlheinz Stockhausen pioneered electronic and serial techniques in compositions like Gruppen for 3 orchestras. Part 6: Impact and Legacy. Serialism has had a profound impact on the development of contemporary music. It challenged traditional notions of harmony and form, paving the way for new experimental approaches. While some composers and listeners find its complexity daunting, others appreciate its intellectual rigor and innovative potential. Conclusion: serialism represents a pinnacle of music theory in the 20th century, offering a highly structured yet creatively expansive approach to composition. Its influence can be seen in a wide range of musical genres and continues to inspire composers to explore new frontiers in music.